So this is a short video by me, Madison, Christian, and Jack. We made a short slideshow. So the molecular formula is just the basic formula of the bonds and mixtures or molecules. So multiple elements that are together. And they show how much of the element are in, or they show how much of each element are in the molecule. So if there's something like H2O, there's 2 hydrogen. If there's something like CO2, there's 2 oxygen, and so on and so forth. So this is a standard form, but when there are formulas with lots of elements, you might want to simplify to get the empirical formula. So the empirical formula is a chemical formula in which the subscripts represent the relative quantity of each element and the smallest whole number ratio of atoms. So basically, that means that it is the same quantity, but it is simplified, so the ratio is the same, but you are simplifying it so it is a smaller number, and therefore it is easier to look at. Empirical formulas are useful for identifying compounds when the only data we have are the percentages of each element. And the conversion is essentially simplifying with keeping the same ratio, like I said. If one of the elements cannot be divided by the same as the others, so if you can't keep the same ratio in whole numbers, then the molecular formula in empirical are just the same. Then polyatomic ions are not normally written in empirical form, but in some cases they can be. So examples: glucose, C6H12O6. You divide by 6, and then you get CH2O. So this is wrong. You divide by 6. And then this one, C5H10O5. You divide by 5, and then you get CH2O as well. And then this one is a polyatomic. So you have 2 aluminum, and then 3 carbon, and then on the outside there's another 3. So you can just like multiply this, and then you'll get that. So that's like a polyatomic one, but it's pretty rare. And then, so you multiply 3 times 3. And then this one is like, if you have the grams of like a molecule and you have 2 different elements, you can divide one of them by 1.9, so you have the ratio of 1 to whatever this is, and then you divide both of them by 1.9, so you have a 1 to 2/3, and you can times by 3 to get a whole number, and you'll get a 3 to 2 ratio. That's it.